It's one of those facts you memorize, right? You memorize them. It's one of those properties, exactly. One of those properties. Shall we? Shall we? Let's use our halves as a model. This is a little aside. This is a little aside. But we looked at some powers of 1/2 today, correct? So we looked at 1/2 to the 4th power, and I don't think anybody doubted that was 1/16. A half times a half is a quarter, times a half is an eighth, times a half is a 16th. I think we're all okay with that. Seems like you guys were anyway. And then a half cubed, I don't think anybody had any problem in the room saying that was what? A half times a half is a quarter, times a half is an eighth. I think we're okay with that, yes? A half squared, I don't think anybody in the room had a problem saying a half squared is what? 1/4, exactly a quarter, 1/4. And then a half to the 1st power, I don't think anybody in the room thought that was anything except 1/2. So you see, what's happening here is these exponents are decreasing by 1, right? 4 minus 1 is 3, 3 minus 1 is 2, 2 minus 1 is 1. The next one in line is going to be 1/2 to the 0, which is down by 1, correct? So the pattern will continue into that. Now, what's the pattern between this and this? How do you get from 1/16 to a 1/8? Marion? Say it reciprocated, if you would. Which one's bigger? Which one's bigger, him or her?
Double.
Good. Don't you multiply this by 2 to get from there to there? It's multiplied by 2. Now let me just say with a half. Half from here to here, 2 times from here to here. Does that pattern continue as we go down? Is this times 2? Is that times, is good? Is this times 2? Is the pattern continuing?
Yeah.
Times 2?
Yes.
So that means to get to the next one, we got to do a half times 2,
1.
which will be 1. Now, don't believe this. Don't believe this right now. In order for it to be a true pattern, it would have to continue past 0. What's the next integer past 0? 4 to 3 to 2 to 1 to 0? -1. Let's keep the pattern going. 1/2 to the -1. What is 1/2 to the -1 power? Do you remember?
1/4? Or no.
It's the what does a negative power mean?
If you multiply on the outside, does it carry over?
It does, it does. Hang tight though. What does a negative exponent mean you have to do to the number in the parentheses? Do you remember this?
Absolute values?
Now, not absolute value, it's the reciprocal. By definition, this is how it's defined, just so you know. This is how it's defined. A negative exponent means you reciprocate the number inside. That's by definition, it's a reciprocal. So 1/2 to the -1st is 2 over 1.
Oh.
Or just 2.
Okay.
Fair? Now, going with what Ashley was saying, 1/4 to the negative, excuse me, 1/2 to the -2 would be 1/4 to the -1, which would be 4 over 1. It's the you reciprocate inside and then apply the power. So the negative number means reciprocate, then you apply the power. 1/2 to the -3rd. Guys, don't panic. I see fright in your eyes right now. Don't worry about these aren't part of 105. I'm just proving to you the pattern holds. So if this is making you nauseous, just deal with it for 30 seconds and we're done. This is, well, 8, careful, 8. Because it's exponential growth, it's cubed, not times 3.
Oh, okay.
And then 16 with 1, but you see the pattern's continuing?
Oh, yeah.
2 times 2 is 4, 4 times 2 is 8, and 1 times 2 is 2, which means 0 sits right in there beautifully. Now, some of you might be sitting there and going, okay, it works for a half. How about for a third? How about for 4? How about for 2 points? Is that what you're thinking, Josh?
No, I had something else.
Oh, good. Hold that thought. Trust me on this one. This argument works for every single possible base you could use, except for the number 0. Because you can't divide by 0. The division problem breaks down. That's why you can't raise 0 to the 0 power. You can raise anything else to the 0 power, and it becomes 1. And that's pretty badass. Now, why is it good for us? Why is it good for us? This negative stuff's making you upset, and I apologize. I'm going to get you in a second, Josh. Just give you 30 more seconds. Don't worry about this negative stuff. If you were okay over here, I'm a happy dude. We tend to do this backwards, though. The reason it's good for us is when you are looking at our data results,